All right. Thank you so much. My name is Elizabeth Schulte. I'm the marketing director for PlanIT Geo. We're really excited to have the opportunity to host all these presenters today, and we're very happy to have all of you attending. I'm not going to take up a whole lot of your time, but just for housekeeping, make sure, well, you're already all muted. Make sure and put any of the questions that you have in the chat. I'll make sure and try and make sure that they're addressed. And then I'll have a slide at the end. We actually will send all of your names over to ISA for CEUs, but sometimes it takes about 4 or 5, 6 weeks. So have patience in that, but I will show a slide at the end if you have questions of where to send them to. So, Rachel, you have the floor.
All right, well, thank you so much, Elizabeth, first and foremost for the opportunity. Thank you also to my esteemed co-presenters. And we have kind of an action-packed hour for you today that we are really thrilled to be able to share with you. And so I am going to get started. Can everybody see my slide? Great, awesome. So the title of our presentation, as you all saw, is Getting Ahead of the Infestation Enhanced Tree Monitoring Feature in TreePlotter. So our understanding is many of you joining us today on the call are either current or potential TreePlotter users. And what we want to do, and we're thankful to have the opportunity to do from Elizabeth, is share with you a new feature that you can incorporate into TreePlotter. And that feature is a tree health monitoring protocol that will ultimately help you proactively manage your trees in the threat of insects, diseases, weather events, etc. So, come on. All right, here we go. We'll do it old-fashioned. So the biggest question that we at the Nature, and by the way, I should introduce myself, Rachel Holmes, Urban Forestry Strategist for Cities Network at the Nature Conservancy. And I've been working in partnership with the U.S. Forest Service now on an effort called Healthy Trees, Healthy Cities since 2014. And we started this partnership really with the big, broad question of, are we doing enough to proactively protect our trees? So as many of you know, researchers like Dave Nowak have shared with us that by far and away, the greatest value of our trees is in long-lived, large trees. And there is a specific period of time during which those trees provide the most ecosystem services. So it's in our best interest to ensure that our trees, especially in cities, make it at least between that 30 to 60-year window when they're providing optimal ecosystem services. But we also know that while those trees are working their butts off to try to provide us with benefits, there are some real significant threats to these trees. And so I hope you appreciate the ghosts of Christmas past, present, and future. Obviously, gypsy moth, currant, emerald ash borer, and then who knows what's going to happen in the future. But the point being here, folks, is that we already know that there are significant impacts to our nation's biomass already with known insects. That doesn't even say anything about the insects that we can expect to see over the next couple of decades. And so, as I mentioned, I wanted to share with you very briefly what Healthy Trees, Healthy Cities is. It is an initiative, as I said, with the Forest Service that we've had since 2014. We focus in on tree health monitoring, again, with the eye toward protecting mature trees especially, but ensuring that our tree canopy makes it to those critical years. We have a suite of free tools and resources. We have a smartphone application, project management dashboard, and education and training resources. But this is where we want to zero in today, folks, which is on the data. So there is a national application for the data that is collected through this initiative, and then there's also a local application for the data collected. So let's just unpack that briefly, because this is where this talk comes in today. So just look at the local implications for the tree health data that we are encouraging partners and others in the community to collect. So it obviously will help you, or we hope it will become obvious to you, that it will help you with the early detection of known insects and pathogens. We also know that it will serve as a proactive method of surveillance for unknown threats that we're not quite sure yet. It's also a means to prioritize management response. We do know that the needs of our trees are growing while our budgets are shrinking. And so one of the major benefits that these tree health metrics can provide you with is a way to prioritize the sickest trees that need the greatest attention in the shortest time. And then finally, we'll hear an example today that Michelle will share with us about an instance where these tree health metrics were used to actually secure significant funding to help manage trees. And then while this information is extraordinarily helpful, we feel, at the local level, there are also national implications for that data. So for example, the data gathered, especially through your efforts with TreePlotter, will help support research in tree health nationwide. And even more importantly, you're going to help us identify trends in tree mortality and decline proactively across the country so we can get ahead of these threats. So just by way of introduction for today's talk, we'll start off with just the science of the tree health monitoring metrics that we're encouraging you to adopt within TreePlotter. The second speaker that we'll have, and Dr. Rich Hallett, by the way, is with the Forest Service. Hopefully he'll just give you a little blurb of who he is. Then Dr. Michelle Johnson, also a Forest Service research scientist, will talk to us about an example where tree health data, as I said, was used to secure additional FEMA funding. And then finally, Siobhan Watson, who has joined us today from the New York City Housing Authority. We're very thrilled to have her here today. She's going to provide the sort of real world reasoning behind why a stakeholder, urban forestry stakeholder and manager might invest in the time to conduct one of these tree health assessments. So without further ado, I'm going to turn it over to Rich. Rich, I will be driving, so if you want to just give me a heads up when I can advance the slide.
Great, thank you, Rachel. As Rachel mentioned, I'm a research ecologist with the U.S. Forest Service. And Rachel asked me to describe sort of the genesis of this methodology and where it all started. And I started my career studying rural forestry. Like many of my classmates, I didn't like people and I wanted to get out into the woods. And so I immediately went into studying rural forestry. And I had the opportunity to join a team of scientists that were exploring methodologies in remote sensing technology. We can look at the next slide here. And thinking about what we could do with remote sensing technology, I was pretty interested in forest health issues. And at that time, hemlock woolly adelgid was becoming a problem here in the northeastern United States. And so we did some testing and experimenting and learned that if we looked at spectra, reflected light signatures, as you see on the right, from healthy all the way to declining hemlock trees that had been infested by hemlock woolly adelgid, we could separate it statistically. But in order to make this work, we needed to develop methods to assess the health of trees on the ground in our field plots so we could calibrate the imagery. And during this process, we ended up writing several papers showing the applicability of this methodology. The first one focusing on hemlock woolly adelgid in the Catskills, really trying to detect the front of infestation, early stress detection. So it's pretty easy to tell from aerial photography and remote sensing when the trees are dead, but catching it early enough to do something was really our goal in this case. And then in 2002, emerald ash borer was detected, and we shifted our focus into looking at using these hyperspectral technologies to map the front of early infestation of EAB. From this, we wrote a paper talking about how other people could adopt these methods for earlier detection of monitoring forest decline, because of course we recognize that these two pests were not the only pests that we would face in this country. We move to the next slide. I had an opportunity about 10 years ago to move into urban ecology, and I joined the New York City Urban Field Station. And I started to talk to foresters in the city and learned that they were doing the same things we were doing in rural forestry. They were basically mapping dead trees because it was easy. And I talked to them about some of the work we'd done on earlier stress detection of trees and whether they would be interested in sort of the idea of moving beyond alive or dead surveys or mortality surveys. And there was interest because, of course, when the trees are dead, it's too late, just like with people. We move to the next slide. So I worked to adopt some of the methodology that we developed for rural settings to an urban setting, really thinking about the individual tree, but not only that, thinking about non-stressor specific evaluation of tree health, because we don't necessarily know what could be causing the stress. We wanted to detect it early enough before the trees were dead. And we wanted it to do it in a way, a methodology that was accessible to all levels of expertise. It had to be scientifically rigorous for the scientists that wanted to use the methodology, but also realizing that we never have enough money to look at all the trees in the city, the urban forest management people and personnel. We wanted to engage citizen scientists, non-experts, people that could perhaps go out and do some of this work and get valuable data. Next slide, please. And so we developed the methodology looking at visual estimates of the tree crown. Don't need any special equipment. We worked out some methodology where we worked in pairs. This is exactly what we did in rural forestry when we were doing our calibration plots. And we wanted to really come up with defined rubrics and classes so they were well understood. And we have rules. It was basically a set of rules to the game. So here's a rundown of some of the metrics. We're looking at the crown of the tree. So we're ignoring the trunk and the base of the tree. The crown of the tree is where we see the earlier signs of stress, regardless of the stressor, whether it be drought, harsh urban conditions, fungus, or insects and diseases. We're looking at 6 tree health metrics. Fine twig dieback is an estimate of the small twigs in the upper and outer parts of the crown, leaf discoloration, leaf defoliation. A crown light exposure is really an estimate of how much light the tree might be getting, which we can correlate with some of these stress variables. Crown vigor is a holistic view of all of the variables that we look at for stress and coming up with a single rating based upon a set of rules. And then crown transparency, we look at that because when trees start to become stressed, they start to put less energy into creating new leaves, which impacts their ability to photosynthesize, or sometimes they drop leaves, making the crown thinner. Next slide, please. Once we developed this methodology, and again, really thinking about using it with non-experts, we decided to test out the methodology with a group of Boy Scouts in Wisconsin. My nephew came to me one day and said he was looking for an Eagle Scout project to do, and he had noticed that a lot of his trees in his town in Oconomowoc, Wisconsin had been dying. And of course, I knew about emerald ash borer because we'd been studying it, and I asked him if he'd like to pilot some of these methods and assess the trees in his city to help the urban forester, which didn't have the opportunity or the resources to go out and survey the trees since they'd become infested. What I did was I started them out. I did a couple hours of training with the Boy Scout troop, and most of the way through the summer, I learned that they finalized the survey. They'd surveyed all 300 ash trees in their town, and I quickly got on a plane and went out there and remeasured 20% of those trees because I recognized this as an opportunity to test the viability of the data they collected. How could non-experts, how well could they do in the data collection, and would it agree with the assessments that I made of those same trees? You can see on these two graphs, the assessments that the Boy Scouts made did not perfectly match the assessments I did on those same trees, but they were awfully close. On the graph on the right, you can see where the assessments deviated the most, and this was sort of in the middle when the trees were becoming more sick. As you go up to the right, you see these trees becoming more stressed. We had pretty good agreement. And on the bottom left, we see that the healthy trees, we also had pretty good agreement. So there's a little bit of variability in the measurements in the center of this graph, but overall it was pretty good. Next slide, please. My nephew was able to create a map of the trees in his city, showing which ones were most stressed. The city forester then took this map, and his urban foresters now had a prioritized list of trees based upon their DBH, their size, and their stress index, which allowed them to, instead of having to go to every single tree, they went to the trees that were biggest and sickest to do further evaluation to see if they needed to be taken down or were they a hazard or not. Go on to the next slide. At this point, I'll turn it over to Michelle Johnson, who joined me in New York City in using these methods for a scientific study on the impacts of Hurricane Sandy on the health of trees in Queens.
Great, thanks, Rich. So yeah, today I'm going to talk about looking at the effects of flooding on trees in Queens. And part of the reason for this work was to think about funding to from FEMA for city agencies to be able to respond to damage that happened after Hurricane Sandy. Next slide, please. And so what happened is when Hurricane Sandy hit in 2012, 48,000 street trees were located in the area that was flooded by Sandy. Next slide. And ultimately at the end of this study where we looked at the effects of this inundation on street trees, we published a paper in Landscape and Urban Planning that evaluated these impacts using the tree health method that Rich described earlier. And I'll drop a link to this study in the chat after I present this case study. Next slide. And so New York City Parks is responsible not only for parklands, but for street trees in New York City. And they, after Sandy hit, went out and did a late leaf out survey in the city. And what they observed is that street trees in the inundation zones of Sandy weren't leafing out as expected. So they went out and did a broader study in 2013 and 2014 and assessed this leaf out. Next slide, please. And we're really kind of evaluating that leaves weren't leafing out properly. And they saw also all of these work orders coming in. You can see how they are divided by borough here, and that there were a large number of work orders related, and that there are also a similar amount of street trees that were flooded. So thinking there's a link in this relationship between damage or effects of flooding onto these street trees. So next slide, please. They approached Rich, myself and Nancy Santi, and said, hey, it'd be great if we could do a study, scientific study to really evaluate this in more detail beyond this, broad monitoring approach with the late leaf out study. And so sitting down, Rich and Nancy started developing these questions. Did saltwater flooding have a significant impact on street tree health? If flooded trees are showing signs of stress, will they recover? And also, are all tree species equally sensitive to saltwater flooding? Hit next, please. And what, looking at from the late leaf out study, we could see which species were flooded. 22% of those were London plane, 2.5% of those were red maple. Next, please. And next, please. And so red maple, as many probably well known, can really thrive in a wide range of environments. And at the same time, London plane trees are really already known to be damaged by road salt. So here's an example of a relatively tolerant species to environmental conditions and a relatively sensitive species to environmental conditions. So these were two species we selected in the study. Next slide. And we looked at monitoring tree health measures for these trees, both in flooded parts of Queens and not flooded parts of Queens. Next slide. And we did this for 3 points in time, and looking at red maples here and looking at the mean Z-score or stress index that Rich was showing earlier, we can see flooded trees were more stressed than healthy trees initially, but then they started evening out over time and recovering. And with London plains, we saw a difference here in that the unflooded trees and the flooded trees started diverging over time, and that the London plains weren't able to respond as well for those that were flooded. Next slide. And also, just looking at overall mortality, in addition to these tree measures, we can see that the flooded London plane trees really had a high level of mortality relative to red maple. Next slide. And so this was a study to basically be able to demonstrate, hey, there are tree species that are being affected by saltwater flooding. It's happening as a result of a storm like Sandy. We also did some scenario modeling to think about Sandy is not the only storm that's going to come and create the saltwater flooding in the New York City area. What might be other impacts in the future that could happen? And so we looked across a series of scenarios of inundation scenarios. And just starting off, we looked at what's everyday flooding that's happening right now. And so already there's 42 kilometers of roads in the city that are susceptible to coastal flooding at any point in time, regardless of a storm. During Sandy, this number is much larger. Over 1,400 kilometers of roads were flooded. But by 2080, looking at scenarios, this figure could double. And so if we extend this kind of thinking out beyond New York City, we can see that there are really a large number of roadways in the eastern U.S. that could be susceptible to the everyday shallow coastal flooding, but also even much larger to these storm surges and events that are increasingly happening. Next slide. And so we started thinking about how might cities handle this, increasing storms, increasing potential for flooding of saltwater and effects on species. And so first looked at thinking about what species do you select to plant going forward. So if we can learn more about which species are salt tolerant, then we can start planting species that are more likely to survive in these flood-prone coastal zones of cities. Next slide. And then also we can look for genotypes that are hypertolerant to salt in these salt-tolerant species. And so this is even digging further into beyond just species selection, but really selecting certain, varieties of those species that are going to be even more tolerant to places that will be flooded, to best be able to still have street trees in these areas that are going to be flooded multiple times in the coming decades. So this is just an example of how you can, start with a study of a couple of species, use it to justify some funding for responses, but also use it to think about moving forward what might be some other strategies to use. And we've given this example with just a couple of species, but you could extend this to think about the full spectrum of street trees or species in parks and the like as well. With that, I'll turn it over to the next slide and turn it back to Rachel.
Awesome. Thank you so much, Rich and Michelle. And it is just always such a joy to work with them and then also just see and hear all of the great work that they have underway. And so what we just heard were two examples of previous in Rich's paper with regard to the untrained citizen scientists in Wisconsin, and then of course Michelle's example of flooding in New York City. Those are two examples of how the data are being used for management, and in the case of New York City with the flooding, how additional funds were secured to be able to continue to do maintenance. And so what we want to do now is just change directions just a little bit and invite our colleague Siobhan Watson from the New York City Housing Authority to share a little bit about an assessment that was done in 2019 on New York City Housing Authority properties. And by the way, it's NYCHA. So there you go, Siobhan. You won't have to keep saying the whole thing over and over. And she also represents the sort of practitioner who has to make a lot of important decisions about how to move forward with the protection of the resource on those campuses. So I want to turn it over to her, and then we will share a few concluding slides with you, and then we'd love to open it up to questions. And I see some of them are coming in, so hope you don't mind. We will have a good Q&A session at the end of our presentation. Take it away, Siobhan.
All right, thanks, Rachel. So I have been lucky enough to work with Rachel and Rich on a tree assessment at the New York City Housing Authority, also known as NYCHA. I work at NYCHA as program manager for climate adaptation initiatives. We're looking at climate threats that are facing the Housing Authority and how we can mitigate those threats going forward. So trees are an area of particular interest for us. NYCHA is We have about 2,400 acres of land, over 326 housing developments in the city, home to over 400,000 New Yorkers of low and moderate income. So there are a lot of residents who live in these developments and get a lot of important shade, access to green space, and other benefits from our trees. And what we've realized as we take a look at what climate threats are facing us is, number one, that trees are one of NYCHA's greatest assets in terms of managing some of the threats, particularly heat and stormwater, but also that we face threats to our trees and are interested in learning more about how we can protect that asset and make sure that we continue to value it going forward. Ooh, not sure what happened there, but
that's me. Excuse me 1 second. I noticed there was an issue with the slide. So hang on just a second.
yeah, no problem.
All right, resume share. Here we go. My bad, guys. All right, here we go.
Sure. So what we're seeing right now is a NYCHA campus, Carver Houses, which is in East Harlem. And it's one of two pilot sites where Rich and a fellow from the New York City Mayor's Office conducted kind of a pilot tree inventory and assessment in 2019. And one of the interesting things that was found there was that the number of trees was actually sort of an order of magnitude larger than what was estimated from imagery and records of what had been planted there originally. So that is, on the one hand, great because we have a lot of trees. On the other hand, overwhelming to sort of identify priorities and management strategies for these trees. So this is Carver. I believe the next slide is Tilden. And that's a campus in Brownsville in Brooklyn. So if you move to the next slide, Rachel, these two sites were inventoried and assessed using the Healthy Trees, Healthy Cities app in 2019, or the Healthy Trees, Healthy Cities methodology. I'm not sure the app was done at that point, but these were mostly done by people who were not trained in forestry, but used that methodology along with Rich and his guidance. And the results prompted us to dig further into trees at NYCHA, right? So the predominant species, London plane tree, which of course we know we have a lot of London plane trees. Again, there are concerns with the resilience of London plane trees, and we've been thinking a lot about that at NYCHA, particularly for flood-prone sites. But the Z-score, that stress index, was pretty high. So looking at the number of trees with a higher stress index, it looks like we had about 3/4 of the trees at both campuses or more were in those higher stress categories. So that is concerning. If you move forward, Rich did a comparison of those trees to citywide trees and found that on average, NYCHA's trees were actually more stressed than New York City street trees overall, which is a bit surprising given that many trees in NYCHA's campuses actually do have more room around them rather than being in tree pits. Next slide. And one of the things that I think is a real advantage here is not just looking at the stress of the trees, but our ability to see that in a spatial format. So looking at these maps of sort of where the high stress trees are, we have limited resources. We can't necessarily invest in all of our trees. So that ability to prioritize management needs is very important for us. But also looking at kind of landscape types. Are there certain types of landscapes that we have at NYCHA where the high stress trees tend to be concentrated? Certainly at Tilden, you see that central corridor across the campus looks like a particular cluster of high stress trees. So we're just interested in identifying, are there particular types of areas within our developments that might need extra attention with regard to tree management. So what this inspired us to do was to launch a new tree assessment for this year, where we expanded this to 18 campuses. Rachel, is the slide with those pictures still in here? Yes, okay, great. So this is some pictures from our tree assessment this year. So we partnered with the U.S. Forest Service and with the NYCHA Conservancy, as well as with Green City Force, which is a great nonprofit organization that provides green jobs training to young adults who are NYCHA residents. And we were able to employ some of their alums who had gone through a green jobs training program, more related to urban farming, not related to forestry. Rich and Rachel helped us provide some training on tree inventorying, as well as early pest detection. So we didn't do the full tree health assessments this year because it was too late in the season by the time we got started, but we are hoping to continue that in the future. But we did do some of the early pest detection work and worked with our Green City Forest alums to do that. So it provided a really nice green jobs training opportunity, quick onboarding and training process that let them get out in the field pretty quickly and start collecting this information. So we'll have quite a bit more information about our trees after we've analyzed some of the data for this year. We're looking forward to continuing to work on this, and we're excited that the U.S. Forest Services and TNC are kind of able to help us with this information that we think will benefit NYCHA's trees for years to come.
All right, well, thank you, Siobhan, for that. And as I said, what we wanted to do with our time today was share with you, number one, the science behind the methods. Number two, a very brief snippet of what the methods are, those 6 metrics, tree health metrics. And then also provide you with a few examples of how that data has been used to advance urban forest management and planning in a variety of real-world situations. And so just a few concluding statements for you, and then we'll go into some possible next steps for you to take. So the very first thing, and by the way, I should probably be fired. I'm like the worst PowerPoint driver here, but here we go. All right, so very first, our trees are absolutely at risk. And we know that proactive monitoring can help protect your forest resource that we know so many of our municipalities depend on so much for benefits. Also, we wanted to, hopefully you were able to gather from these examples that no prior experience with tree monitoring is technically required for this methodology. And as Rich pointed out, the methods were developed with the untrained data collector in mind. With that said, we do want to be upfront and transparent in saying that some familiarity with tree identification is definitely a plus. And just to give a concrete example, one of the metrics is leaf discoloration. And so we're asking people to look at whether the leaves are, have any kind of discoloration to them. So it does help to understand what that typical leaf should look like, so you can then detect whether there's any kind of discoloration. But our point here is that we have worked with citizen scientists. We've also worked with municipal tree staff and municipal staff who maybe are, in the Department of Public Works or Department of Transportation that are maybe not affiliated with the Parks Department, but definitely can pick up these methods. Also, we are available for training and support. And so that is in the form of live support. So, we've gotten pretty savvy with how to conduct some of this training in a remote way, since none of us can actually be in person. We also have a variety of print and text resources. And then we also just completed a series of training videos that are fairly comprehensive. Each video, there's one for each of the 6 metrics. None of them are longer than 2.5 minutes. And so it's a really great feature for your municipal employees or anybody else working with you to be able to get up to speed on the actual methodology. Of course, all of this training and all of this support we will do in coordination with PlanIT Geo. Also, the data have both local and national implications. So as we pointed out, these case studies have shown you that there is definitely a local application. I mean, these data are being used in real time, but then also you're contributing to the broader national surveillance of our tree canopy over space. And then finally, as these case studies have pointed out, data can be used for additional funding, prioritize management response, and ultimately increase the resilience for frontline communities, as the work in NYCHA is showing. So here we are. We're at the point for next steps. Again, Elizabeth, we are so thankful to have had this time with you. You've provided us the opportunity to share with, again, TreePlotter clients, current and potential, what some of these data, these additional data can do for you and do for your tree management program. And so to that end, you can contact us for additional information and resources. So any of the folks, and I'll give all our email addresses on the next slide. But you're more than welcome to reach out to us if you want any additional information. If you want links to some of the papers, I imagine we'll do a follow-up email where we can supply you with a lot of that information ahead of time. But then also, and perhaps even more importantly, contact your PlanIT Geo representative so that you can incorporate these tree health metrics into your version of TreePlotter. And so, yeah, so I'll wrap up by saying that we're extremely thankful to Ian Hanu, to Elizabeth, to your team for working with us to help bring these tree health methods and these tree health assessments to life. And the last thing that I'll say, guys, is that above all else, we are just really reliant upon the good work you do to help all of us working at the national level be in a better position to protect our trees. So all those data really do help, and we very much appreciate the work you all do. So here's our website, healthytreeshealthycities.org, and then also the Forest Service YouTube channel has training videos. That's where they all live. And these are our email addresses. So please do feel free to reach out to any of us. We are very happy to support you, and that's kind of why we're here. So for that, I will turn it over to, I'm actually going to stop sharing, and then I will turn it back over to Elizabeth.
Thank you, everybody. I really appreciate it. Great presentation. We do have a couple of questions that came through. John Harris asked or made a statement, we continue to find major environmental impacts that severely damage or kill so many trees, saltwater flooding and below ground saltwater intrusion too, climate change, insect infestations, and human-caused development clearing too. Having to change from usual or commonly available species for planting to newly recommended species that are not currently likely to be damaged or killed by these known tree killers is high-level thinking and not easy to communicate as a must do this recommendation. How have any of you been overcoming the pushback from cities and contractors and nursery growers for changing what to plant next? So there's a lot to consider there. But if there's any feedback there from any of the attendees or any of the presenters that they would like to chime in on, sounds like specifically kind of thinking about the availability of these species.
Yeah, I can chime in a little bit. Thinking about New York City in particular, it took a catastrophic event like Hurricane Sandy to push the agency to consider replacing those trees that they lost after the flooding with some salt-tolerant trees. And they've been working on a salt-tolerant tree list and really being pretty proactive to try and figure this out. Not all cities are that nimble. And it took a big push in this case. And then there's other things to consider like global heat island effect, and that, you know, maybe some trees from the south would do better as we experience global warming.
I'll maybe add in doing in thinking about climate change in with the urban forests and cities is building demo projects. Demonstration projects that really can highlight success or what would happen if you had planted certain species that would be more tolerant of future conditions. And so we have some work that Rich is really heavily involved in Philadelphia, in New York, and Baltimore, other cities up and down the East Coast. And another thought is here in New York City, we have the good fortune to have a native plants nursery that the New York City Parks Department runs. And so they were kind of already poised to pivot in that way with already having some thinking around these ideas. And I think maybe looking to some nurseries that maybe are already forward thinking in other ways might be a direction to look at for how to pivot in terms of climate.
Awesome. I remember when I worked at the DNR, I'd always tell homeowners, if your neighbor has that tree, that's not what you want. You want something different. I haven't seen any other questions come through. I'll share my screen very quickly to show the ending slide about the CEUs. And I also just wanted to point out, if you are a current TreePlotter user, you can contact us and we will add these fields to your app for free. So if you want to try this or play around with a new way of collecting that data, you can reach out to us and we'll add that anytime. So hopefully you guys can start to get more familiar with this or practice not only in your TreePlotter app, but also in the HTHC app. So any more questions out there? Oh, looks like another question came in.
I think it's a comment actually in response to the previous question. Yeah.
Got it. Okay, awesome. Thank you.
And actually, Elizabeth, before you put that slide up, there are a few folks, and actually I'm just curious to hear who of these participants that have joined us today have familiarity with these methods. And I know of at least one, Tricia Bethke, who is the Forest Pest Outreach Coordinator for the state of Illinois, who has been one of our greatest champions of these methods and of the tools. And in fact has been one of the masterminds behind a really cool application of these data in Chicago, where we're trying to understand the implications of tree health and the relationship for human health. And so she's been working on a project with us and Rich and Michelle in Chicago. But just curious, have others either heard of the methods or have any of you tried Healthy Trees, Healthy Cities app, or have you worked with the methods before? Maybe you can just express in the chat if you have. And then I have a follow-up question, if we could, Elizabeth, after that.
Yeah.
So yeah, the question is, have you worked with any of these methods? Cool. All right, so similar methods in ISA tree risk assessment protocols we use daily as private consultants. Excellent. ExxonMobil Conservation is using the application too. Hey, high five.
Ooh,
that's all you.
John Snow says, I've looked at it.
Great. And the follow-up question that, we're always curious to know is, of those of you who are managing a municipal or even a private tree resource, how are you currently evaluating tree health? That's always a question we're curious to know. Cool. Somebody's familiar with your Oconomowoc study, Rich. That's awesome. He's famous. And by the way, Rich is actually famous. He has his own trading card. So just saying. That's when you know you've arrived in your career, guys. Awesome. And Tricia uses the data as a roadmap for education and outreach as well. Cool. Well, I will, I know you want to get the CEU slide up, Elizabeth, but I can't overstate the commitment that Rich, Michelle, and I have to supporting anyone that is interested in incorporating these tree health evaluations into TreePlotter. We're very willing to, help coach you through different ways to teach the metrics to people that you work with or that you want to engage in volunteering. We're very happy to share our resources, and so we really, truly mean that.
Awesome. I will share. Can you guys see it? And all my millions of tabs that I have open? Any more questions? Let's see. Oh, looks like we had a couple of more answers come in associated with your question.
Great, I just took a peek. Thank you guys for responding. We really appreciate it.
All right. Like I said, we will send a list of attendees over to the ISA. And so you do not have to worry about sending in a CEU code. And just give us a little bit of time. It takes a little bit for the ISA to process all those CEUs, especially probably since they have ISA going on this week. It might be a little bit slower. So a little bit of patience in that way. And we really appreciate you attending the webinar. We're very appreciative to Rachel and the speakers for this opportunity to learn.